Hello, I'm Luke, and I'm going to talk to you about monitoring today. So monitoring a microservice can be a bit tricky. You need to think a lot more about network and communicating with lots of other things that you mightn't have thought about in your monolith. But I'm not going to talk about that today. Even trickier is when you have a group, like all your microservices in your team, and trying to keep track of all of those together, how they're doing, different failure states between them, how they interact, and all that sort of stuff. That's a much trickier problem. I'm also not talking about that today. What I want to talk about today is how do you monitor every service across your entire organization. So a bit of background. I work for the Financial Times. Probably interested what sort of tech stack we use. So we use Go microservices, and they're on Kubernetes, which is running across regions. We use CoreOS on EC2. Actually, wait a sec. Let me just do that again. At the FT, we run Node.js microservices. We deploy them onto Heroku using Circle CI, and we have a CDN in front. Oh, is that right? No, well, another go. Our Node.js microservices, we deployed them onto AWS Lambda using a serverless framework, and we put that all behind an API gateway, so we can present them all as a single coherent. Actually, what we do is we have a PHP monolith, and we deploy that using Puppet. And we've got a Jenkins box that kicks all that off, and we have Varnish sitting in front of that, which is a reverse proxy server and does some caching. Actually, OK, one last go. We write Java apps, and we deploy them using Apache Tomcat onto Red Hat Linux boxes. We run these on-premise in our own data centers on Cisco UCS, and they're fronted by 2 manually configured Jet Nexus load balancers. OK, you're going to ask me now, Luke, you've just given me 5 different contradictory things. Which of these does the FT actually use? The answer is all of them. And actually, we use a lot more architectures than that. It's not just those. There's tons and tons of different ones. I could go off in details of lots of different things. The reason we do that, we decided a while back that we wanted to empower teams to make their own technical decisions for what works for them, which is really, really good. It speeds up delivery. Teams can go off and say, this works for us. We're going to do this. But what it results in is just this wide variety. And that comes tricky when you're trying to monitor things. We do a lot of different things at the FT. We have a website that you might be familiar with, ft.com. We also, 6 times a week, we print off a version of that, and we send it out to people. You might have heard of that as well. But we also have various other services, the How to Spend It, Investors Chronicle. And then we have internal-facing apps as well for our staff, so CMSs, sales things. Lots and lots of different tools that we build. Our brand team would like me to tell you that we have 130 years of quality journalism at the FT. As a technologist, I look at that, and I go, do you know what that actually means? That means we've got 130 years of legacy that we have to support. An interesting story, a few years ago in the newsroom, they were trying to push towards a more digital-first newsroom. So we used to always think in terms of getting out the physical newspaper, and now we're like, OK, we want the website to be the first and foremost. So they were looking at the journalists' workflows when they had to file copy, and then from that, the copy would get put together, it would get sent to print sites, things would be printed, they'd be distributed. And they were trying to work out why a certain deadline, this deadline for when a journalist had to file copy every day, it was the same deadline, all the journalists knew, we need to get our copy in by this time. But someone started asking why. Why this particular time? And no one really knew. They just knew that was the way it was done. And so they drilled back through history, and they tried to work it out. And it turns out that the reason they filed copy was because of steam train timetables from the 1900s, because they needed to get the newspapers on the last steam train from London to Edinburgh so people in Scotland could read the newspaper. Nowadays, we have better ways of getting news to people in Scotland. They don't need to wait for a steam train to arrive. But no one had ever revisited this. They'd just be like, that's the way we do it. we'll keep on doing that. OK. So at the FT, we have quite a few different monitoring systems. Sorry, just let me have some water. We have a bunch of different monitoring systems, and these have sprung up. Each of these different architectures I showed you uses different tools behind it, and other people have just decided, I want to use this here, I'm going to use that there. And we were trying to get a grasp of how do we keep track of all of these things? There's so many things going on in different places. We didn't want to replace these all and build the one monitoring tool, you must use this, because A, that's really hard, you have to get all the teams to buy into that. B, for some really old systems, you don't necessarily understand that old system. Pulling out all the monitoring from a really old system and trying to replace it with something new can actually cause more trouble than it's worth. So we wanted to keep these monitoring systems in place, but try and get an overall view of what was going on with our estate. So we added a single data store. We used Prometheus for this, so we could pull in lots and lots of different metrics from all these tools, and then we built our own custom front end in front of that. So here's a quick view. I've zoomed out quite a lot to try and get all the services in, but actually I couldn't even fit them all in one slide. We have a lot of things going on. So what I'm going to talk today about 3 main sections. First of all, how do you monitor those legacy monitoring systems? How do you pull them in? Secondly, some current monitoring approaches. And finally, a bit about how you think about monitoring for the future, for the systems that haven't yet been built. So first of all, legacy monitoring systems. So we have a couple of systems in-house that have, they're there. They were often built alongside at the time of the legacy systems and whatever monitoring was put in place. And some people like to sort of shy away from legacy. They're like, oh, let's get off all the legacy. But we realized legacy tends to be the thing that's bringing in the money right now. You probably have lots of dev teams that are off building shiny new things. Shiny new things tend to not be bringing in the current money. It's the legacy stuff that brings most of the money into the business. So it's really important to know whether the legacy systems are working or not. So my first bit of advice to you around this is to admit that you have some, right? If you shy away from it and hide it, you're not going to be able to solve a problem. You need to admit to a problem, and then you can solve it. So be upfront about your legacy. The way we sort of do that is we have a think about which of these monitoring systems do we want to actively encourage teams to use, and which things are we supporting for legacy purposes. So we have a little tool that lists all the different monitoring solutions available, and for each of them, we put just a little tag in the corner saying either it's recommended or it's deprecated. And then when a new developer comes along, they can see, OK, these recommended ones. It's sort of like the golden path approach. We will support you in doing that. But these deprecated tools, we still need to support. We're still using them day in, day out to keep track of systems. But please don't build anything new on them, because that just extends how long we have to support these things. Next, when we were integrating some of these old tools, I think we made a bit of a mistake. We spent a lot of time trying to understand the ins and outs of lots of this monitoring. So we'd spent hours discussing like an NTP alert and saying, is the warning state different than that error state? And how does the severity 3, is the severity 3 more major or less than a warning? And how do these things play into each other? And at the end of the day, it didn't really matter. We weren't changing the monitoring of these old systems. We were just trying to pull it in. So the main thing we should have been focusing on, and we eventually did, was the human reactions, right? So that is, if this thing is to go red, what is the person going to do? We have a first-line operations team who then escalates to delivery teams across the company. And they need to know, when this thing goes red, what am I doing? Am I going to wake someone out of bed in the middle of the morning? Is it something that we can tolerate until Monday when someone comes in and they're going to fix it? It's those things that you need to care about first and foremost. It's what the humans are going to do with the monitoring. After that, all the detail just follows, really. And also, one thing I came to realize when we we're pulling in these different systems is there was a lot of config required to keep track of these. And actually, it's OK to hard-code this sort of config. For example, we had Nagios boxes that were spun up across this estate. Lots of different teams were using them. And as a first pass, we were like, OK, we'll stick this list of Nagios boxes in, just hard-code it in 250 lines of YAML. That'll do for now. And we'll come back and look at it later. But we actually found that once we'd done this, these things rarely changed, right? Legacy, once it's there, if you don't have a delivery team necessarily working on it day in, day out, not a lot changes to these old systems. They have the same IP addresses, they're sitting in the same place. We didn't need to make this config really dynamic, really easy to change. And in fact, having that small bit of friction, so like someone could still come and change it. We had a repo and someone could do a pull request and stuff. But a bit of friction for teams to do that actually really helped with legacy, because often legacy is misunderstood. People may not have touched it in months, if not years. So a bit of friction in the process for changing these things was really, really useful, because people would stop, they'd think, and then they were still able to make the change, but they wouldn't need to. And we actually find that most of the time when people were updating this, it's as part of decommissioning. So they weren't really adding anything new. It was just, it was actually as simple as they'd go in, most of our pull requests looked something like this. It was all red lines, which is my favorite type of pull request. It's just delete, delete, delete. Didn't need to add anything new. And that just tended to be all that needed to happen to these legacy systems. So we never actually went round and built a more dynamic way of configuring these, because hard-coded was fine. So just to recap, on legacy things, the first thing you need to do is be upfront about legacy. Everyone's got it. Just admit it. Secondly, focus on the human reactions to the monitoring. And thirdly, it is OK sometimes just to hard-code a bunch of config. And yeah, that's good. OK, so next I'm going to talk about some current monitoring approaches. So I think the most important thing is to add metadata to your monitoring, right? Monitoring is not there in isolation. You need some context. So in the FT, we have some runbooks. These give some useful information, stuff around how important it is to us, whether it's in production yet, even things like when it was last deployed. But I find that the key bits of information you need sort of come in. There's three questions you want to ask yourself. First of all, if this thing's broken, why should anyone care? Like, your monitoring's going off, but in terms of business use, why should someone care that your system is down? The second thing is then, who's relying on this? We need to send out comms. We want to communicate it it's down. We don't want to bombard the entire company every single time something goes down. We want to be able to target those comms. So we need to understand who's using it. If they're external people, maybe we need to talk to our customer care team so they're on hand to deal with any requests and that sort of thing. And finally, we want to know who can help fix it, right? If we need to get someone out of bed in the middle of the night, we don't want to be ringing the wrong team. We want to ring the right team first. That is ideal. And I'd recommend not to hard-code these things in your monitoring. Often you're thinking about these things while you're writing your monitoring, so you tend to put them in the same place. But when you think about each of these, if we go back, each of these can change independently of the technology itself. So for example, you might have a system that was built for one purpose, and some other team in the business goes, oh, that's useful. We could use that for our thing. I've seen it happen, and then they start using it. Then multiple teams start relying on this for a completely different purpose than you built it for. And you're like, that's fine. Maybe the team that it was first built for no longer needs it anymore, but you've got 3 other teams that started using it. Also, from the engineering side, you might have a reorg, people come, people leave. So the person that you're ringing up to fix it can also change. And these are all organizational changes. These are not dependent on the tech. So putting all this information inside the repo or the tech or with the monitoring itself actually means it's much harder to change. And your org structure will change. I can't repeat this enough times. I think it's the only guaranteed thing in technology is that at some point, your organizational structure is going to change. So you need to be prepared for it. So yeah, you want to make your config as easy to change as possible, because it will change a lot. In the FT, we've built our own tool. We call it BizOps, or Business Operations, and it stores data around our operational stuff and how it relates to the business. And to make it easy for people to make changes, we have a UI. We've also got APIs. Engineers love APIs, so that they find that a much easier way to give us the data. It doesn't matter how people give it data, just make it as easy as possible to make those changes. And because these changes will happen a lot. You might think, oh, an organizational restructure only happens every couple of years, and it's a big announcement, and the CTO gets everybody and tells them a big thing. But actually, there's small changes happening constantly throughout any large organization. You might know about every change, but they are happening. You know, teams are merging, they're splitting apart, they're getting renamed, someone's leaving. We actually found by the time you go through and gather all the information you need about all the systems you're monitoring, the first thing you gathered will have already changed by then. Like, that is the pace of change we have these days with technology. So you need to be prepared for change. For us, we've actually found that a graph model, it makes it easier to make those changes. Because with a graph, there's less stuff to update. To go back to what I said, your org structure will change. I said I couldn't repeat it enough, and I will keep repeating it. So, for example, the way we used to think about our systems is we'd have a runbook, and the system would attach to it. We'd have, say, what team owns it, who the tech lead is, what the cost center is, and a bunch of other information, which in the days of monoliths was quite easy. You might have a handful of these. You'd have to update them every so often. But if you think of microservices, if you've got hundreds of these and your tech lead leaves, or they move teams, you get a new tech lead, you then have hundreds of entries to update, and no one wants to do that manually. And even like writing scripts and stuff is just a pain, just every time you have a personnel change having to update all of these things. So using a graph model, we sort of tease these things apart, and we said, well, actually, the tech lead is the tech lead of a team, and a team can own all these microservices, but when the tech lead of the team changes, we only need to make one update. And then we pull all that information through, and then we automatically surface it on the runbooks. Now, I think it's really important that if you're doing this, so our team's a central team supporting all other delivery teams, you don't want to be a blocker to those changes. It can be tempting. You can think, oh, we're the monitoring experts. We know microservices the best. We know about all these X, Y, and Z. It would be great if, when a team needs to do a thing, they'll just run it by us. It'll probably be fine. We'll approve their PR and X, Y, and Z. But as soon as you add a cross-team dependency like that, it really slows the pace of delivery. You find it anywhere, cross-team dependencies slow down delivery, and the same is here. Being that central team that tries to be in control of everything, you just become a blocker, and every other team will start resenting you. And you really want to trust teams. The teams that build their thing, we say you build it, you run it, you monitor it, right? You manage the config around it. They should be in charge of all of that themselves and be capable of making those changes. And one other thing we find is often you might have a source of this sort of data around who looks after which system, and you mightn't trust it very well. For example, we used to, back in the day, we had our runbooks were just sort of static pages on a Google site, and occasionally someone would go in and make a change, but no one really liked doing it. And we went through, spent a bit of time trying to parse all this information out and at least put it in a data store. But then we looked into it, and we were all a bit sort of like, oh, I'm not sure we can use that. It's, most of it's sort of fine, but this references a team that doesn't exist anymore, and I think that guy left 3 years ago, and we'd look through this and we'd see this as low quality data. And it can be tempting at that stage to go, okay, can't touch that. We'll need to start again from scratch. But we actually found using that data helps drive change. Provided it's easy for teams to make those changes, relying on it for your tooling really helps improve it. So for example, our tool, we listed all the teams for our department based on whatever data we had at hand, and then we gave each team their own monitoring dashboard. Now, this wasn't something that they got to configure. This is something we used the data that we had, and we said, according to our data, you own these systems, so therefore your dashboard has these systems on. So obviously we get some people come to us and go, hold on a sec, we don't own that system anymore, and you're missing this system. And then we turned to them and said, well, this is the data store that we're using for this. So if you have a problem with what you see in this dashboard, update it in this data store. And teams were like, that seems fair. So they went and made those changes. And actually, it really drove the quality of data that we then held. And that's the same data that our first-line operations team used for escalating things. So the fact that development teams were looking at these dashboards and spotting errors quickly meant that actually we had much better data around who to escalate incidents to that I don't think we would have had otherwise. So just to recap on the current monitoring approaches, do embellish your monitoring with metadata, but don't hard code it, right? Keep the two decoupled so people can make changes. And the more you rely on this data, actually, the better the data quality becomes. So now I want to say a bit about monitoring for the future, right? You don't want whatever tool you build to become immediately legacy as soon as you've built it. It's always a risk with these things. You're like, yay, we've incorporated all of the monitoring that we have in the organization. And then you're like, oh, what happens if something comes along the next day? So a key to this, and it's a key to a lot of tech, is focus on the interface, not the implementation. Right? Really think about how the data is given to you rather than necessarily stipulating, oh, you must do it this way. In the FT, we have a JSON standard for health checks that each system can expose. And we find this really useful. It's just a list of fields and some JSON, and then we say, okay, we can parse that. And every team it's up to them how they want to do it. You know, it started off, apps would do it sort of dynamically, and websites and stuff, there'd be a special endpoint for them, but we got to a point where some like data pipelines and stuff were like, oh, well, that doesn't really work for us. We're just going to push this JSON into an S3 bucket, and you can read it from there, and that worked too. And yeah, it's like just having a blob of JSON, that's all we're defining. Teams are free to do it however they wanted. And we actually found that teams started using this JSON in ways we'd never imagined, right? It wasn't just to surface stuff from an application itself. It was also, they were using it to sort of pull in other monitoring systems that we didn't have, which we found really interesting because we never really thought of it that way. And this is where you may have heard the phrase paving the car paths, right? You let teams go off, do what they want with an interface like this, and then you watch what they do and see if you can help them along their ways. So we found that there was a lot of teams, they had a Grafana dashboard, for example, and they wanted to pull in stuff from Grafana. So they'd go off, they'd write a little tool themselves that would expose their Grafana alerts in this standard JSON health check, and then we'd pull them in, it would be surfaced on the big dashboard for the whole company. And that was great. We weren't a blocker for that. They were able to do that. And one team went and did it. Then another team were like, oh yeah, we could do that as well. Then a third team were like, we'll do it. We got to about 3 or 4 teams, and then we were like, okay, this is like, we've not blocked anybody from doing this, but at this stage, we could probably make the whole process easier. And we were able to do this, because we weren't blocking them, they weren't dependent on us, we could do this in our own time, but we got to the point, a lot of people were doing it, and we were like, okay, we'll replace this all with our own Grafana exporter. We'll just pull straight from we have one shared Grafana instance, so we can actually pull straight from there. And we made it actually as easy as teams just had to add a little extra tag onto the end of their dashboards, and just to say what system it was. And as soon as we saw that tag, we'd pull it in and go, yeah, we're going to surface it on your dashboard, your alerts on the dashboard for that team. And one final thing we're starting to think about at the FT is to pull away from monitoring individual microservices. Like, microservices are great, but no one outside of tech really understands them. So we're starting to think more in terms of business capabilities. So one key thing we do in the FT is we publish news to a website. So we have a content management system, and then that pushes stuff to our publishing platform. And then from there, it goes to ft.com, where it gets surfaced and users can read it. Each of these is made up of lots of microservices. For example, the publishing platform looks a bit like this. I couldn't actually fit it all on one slide, but there is a lot going on here, which is great. Microservices let you do lots and lots of stuff. Each of these things can be really specialized. But when it comes to monitoring, often our monitoring goes, oh, this content ingestion for Neo4j is broken, which is great for the developer who's trying to do the thing, but the rest of the business have no idea. The rest of the business, our journalists, for example, they don't care about the content ingestion Neo4j microservice. They, to be honest, don't even care about this whole platform. They barely even care about this pipeline. What they actually care about is the question, can we publish news, right? That's what they want to know. So we're starting to think how we can step back from those microservices and monitor end-to-end whether we're actually doing the thing we set out to do in the first place. So to recap on things you can do to protect yourself from the future is firstly define an interface, right? Don't stipulate what the implementation has to be. Let teams go off and do things however they want, provided it meets the interface. Secondly is to spot patterns when they happen and make them easier. If lots of people are doing the same thing, there's usually an opportunity to make that path really, really smooth. And finally, start thinking about what the capabilities you want to support are, not the individual microservices. So to recap, be upfront about legacy. Everyone's got legacy. Admit it. Makes life so much easier. Embellish your monitoring with metadata. People want to know what this means. Don't have monitoring in isolation. You always relate it back to what the business impact is, and start thinking about these business capabilities rather than just the individual microservices. Cool. Thank you. Does anyone have any questions?
Thank you, Luke, and you're making my life a lot easier. Right, has anybody got any questions for Luke? Anybody?
Oh, there's one.
How do you set up the end-to-end monitoring of a capability?
So there's various ways to do this. One thing we quite like is synthetic checks. So that's where, for example, for publishing, we have like one really old article, and just every 5 minutes, we just republish that. And it's a known article. We're like, OK, we're going to just keep republishing this article again and again. And then we can monitor that. We see then on the website at the other end, has that happened? And then we can check if that stops happening. And I think the beauty of having that sort of thing is it doesn't care about all the microservices in the middle. Because you can have all your microservices that each individually are working fine, but then overall doesn't quite work. Like we've had an incident once where I think it was to do with our image publishing. It went through 4 different teams. Every single team swore that their thing was working fine. All their monitoring was green. But the journalists were like, yeah, but my image isn't publishing. And that's actually what the journalists care about. They don't care about every team within the publishing pipeline saying that their thing's green. You want that end to end. So the more realistic you can make that monitoring, I think the better it is.
Any more questions? OK, put your hands together for a big thank you to Luke for that great talk.